All right, let's take a look at number 11 from the chapter 3 test review. So it says to give exact and approximate solutions. So that's different from the previous two. So we're actually going to have to get the decimal right from our calculator. All right, so let's go ahead and use the quadratic formula for this one, okay? So I'm going to write down the quadratic formula just to ground myself. And then let me find out what my A, B, and C are. So it looks like A is going to be 3. B is going to be -5. And C is going to be -7. All right. So let's go ahead and substitute these in, see what we get. So X equals -5 plus or minus -5 squared minus 4 times A, which is 3, and C, which is -7. And then all of this is going to be over 2 times A, so 2 times 3. All right, we know that two negatives like this, it's going to become a +5. So we'll just put 5 plus or minus. Now underneath the radical, -5 times -5 is +25. And I'm going to do the signs here first. I see that I have a negative times a negative, so I know it's going to be a positive. And 4 times 3 is 12, and 12 times 7 is 84. And for the denominator, 2 times 3 is 6. Now remember, if you're terrible at number crunching, then just put all that stuff underneath the radical in. Oops, let me clear this out. So you would put parentheses, -5. Those parentheses are super important. You'll get it wrong without it. -4, parentheses, 3, parentheses, -7. And then you'll get your, what we're going to get, which is 109, okay? So 25 plus 84 is indeed 109. So it looks like we did our math correctly there. Now remember, this Casio actually breaks down roots for you. So if you put square root of 109 in there, and you just get 109 back, then that means it must not simplify at all. So let me read the blue right now. Simplify your answer, including any radicals and I as needed. Use integers or fractions for any numbers in the expression. Use a comma to separate answers as needed. All right. So let's go ahead and see how my math lab wants us to put this in here. Okay. So we had there we go. All right, we have 5 plus or minus the square root of 109 over 6. Let's check that. Okay, now what does it want for the second part? The approximate solutions are round to the nearest 1,000. Okay. All right, so we're going to have to do our two cases separately. Sorry. Okay. The first one being the plus case, and the second one being space. So we're going to have to put these into the calculator and round in the thousands place. Okay. So we have 5 plus the square root of 109 all over 6. And hit the S to D button right here. 2.5733. 2.5733. So a thousandths place, so tenths, hundredths, thousandths. Because this is a 3, we're not going to round it up. So we're going to use 2.573 as one of our answers. Now I'm going to go back and just change, hit the up arrow. No, just kidding. If you hit the left arrow, then you can get into the problem you previously typed. So it's probably going to be the easiest way to do it. And then get there. S to D. -0.9067. -0.9067. Tenths, hundredths, thousandths. So because there's a 7 here, we are going to round that 6 up. So it's going to be 0.907 for this one. Negative, right? Okay, let's go put those in. 2.573, 2.573, comma, negative 0.907. We put a comma between them. That's what it said. Let's see. Perfect. So you're going to do 1 with the plus case and 1 with the minus case. This calculator is just going to spit the same thing back out. So you have to remember to hit your S to D button if you're using this Casio. Awesome. All right, let's try the next one. Let me grab that, and the rock paper is actually pretty decent on my lab math this time. So let me grab that graph paper too. But big though, let's make it close up. Okay, so it says find the vertex, the axis of symmetry, determine whether there's a maximum or a minimum, and graph it. Okay, so we have a formula for the vertex, x equals negative b over 2a. So we just need to substitute stuff in. So we can see that our a is going to be this -1 that's in front of the x squared. And our b is going to be this -6 that's in front of x. So if we plug that into the formula, negative b, so -6, all over 2 times -1. We'll clean that up. We know that the 2 negatives, right? That's going to end up being a +6. And then 2 times -1 is -2. A positive divided by a negative is a negative, and 6 divided by 2 is 3. So that's going to be the x value for our vertex. But don't forget that we need to take that and substitute it back in here and here to find out what our y value is. So let's do that now. Okay, so negative x squared, so -3 squared minus 6 times -3. Some negatives going on here. Ooh, we better be grounded. Okay, so we have to do exponents before multiplication. So I'm going to do -3 times -3, which is +9. Then over here, a -6 times a -3, well, a negative times a negative equals a positive. Okay, -9 plus 18 is 9. And 9 minus 15 is -6. So we got the y value. -6 is going to be the y value that goes with that x value. Let's put it in. 3 -6. Okay. The axis of symmetry is, okay. So let me graph -3, -6 right there. And for now, I'm just going to put like a fake parabola in, okay? I know my parabola is facing downward because of the negative in front of the x squared. So let's pretend this is my downward facing parabola, okay? Well, the axis of symmetry is a line that cuts the parabola in half. So it must always pass through the vertex. It has to cut it in half. And so because of that, because it always passes through the vertex, you can basically just steal the x value from your vertex. So it's going to be x equals -3. Or you could just draw the line and see, hey, where does the line cross the x-axis at? It crosses at -3. So don't put -3 in though. You have to write x equals -3 because y equals -3 would be a horizontal line. It needs to know that this is a vertical line. So we're going to type in x equals -3. -3 will be wrong. You have to make sure you put that x equals. Okay. So basically, just to kind of point this out, I didn't even need to graph it. I just take this x value, right? X equals -3, and I write that. Now, does it have a max or a min? Well, that comes down to which way it faces. We found out that it faces downward, right? So there's arrows. It's going to go down forever. So it doesn't have a minimum, but it does have a maximum. It does have a highest point. And if you look at this highest point, come over here to the y-axis, it looks like -6 is as high as it's going to go. So you have to determine which way it faces. Upward facing parabolas have a minimum. Downward facing parabolas have a maximum. And you want to make sure that you use the y value, right? To trace it back to the y-axis to find it. So -6 is going to be our maximum. Let's go put that in. The parabola has a maximum value. The maximum value is -6. Okay, now let's get detailed with our graph because it wants that. Okay, so I'm kind of erase some things here and make sure I get more detail. Okay. So for my math lab, it wants 3 points and we already have our vertex. Okay. So to get another point, what you can do is you can use this A, this number out front, as kind of your slope. That's how I like to do it. So if I look at my A, and I'm going to air quote the slope here. It's -1. Don't forget to put it over 1. So we're going to go down and to the right. So I'm going to go down 1 and to the right 1. But we know it's a parabola, so we have symmetry. So I should also go down and to the left 1. That's an easy way to get 3 points. Now, if you forget that, and you forget that the number out front is kind of like your slope, then what you can do is you can pick an x value nearby. We're here at -3. We'll pick -2 and just plug it into the equation and see what you get. So if you plug a -2 into the equation, I'm sorry, guys. Get that back up there. Clean this up here. Okay, so a -2 substituted into the equation. You should get -7 because that's what we got, right? -7 in our graph, but let's go check it out. I'm just going to put it in the calculator because I think that's what most students would do when it starts to get this many negatives. So negative, parentheses, -2, square, 6, minus 7. It is. And then once you get that 1 point, don't forget, we just said that the axis of symmetry looks like this, right? So then you would know that you'd have to have the same point mirrored on the other side. So you don't have to work hard for this point. Once you got this one, just reflect it across your axis of symmetry. So if it's 108 here, it's got to be 108 there, right? And you'll have your 3 points that my math lab requires. So let's go try to put these in. -3, -6 was your vertex. And then we had a point here. Oh, it looks like it only needs one other point. Nice. Okay. Let's see. Perfect. Awesome. Okay, so that was kind of a lengthy one, but not a ton of number crunching. The only thing we really did was this -b/2a and then plugged it back in. The rest of it was kind of like thinking, right? What are all these things called? Which way does it face? So I can see if I have a maximum then. All right. Let's look at this next one here. What are we on? 13. Looks like it's kind of close to the same stuff. So hey, we get to practice it again. So part A says find the vertex. So here we go. -b/2a. And we can see up here that A is going to be the number in front of the x squared, so 3. And B is going to be the number in front of x, so -12. So let's go ahead and substitute those in. So -12. Boy, they're really testing our negatives today. And then 2 times 3. So we know that the double negatives like this is going to become a positive 12. 2 times 3 is 6. And 12 divided by 6 is 2. So for the vertex, we know the x value is 2. But don't forget to take that x value and plug it in here and here for all your x's so you can find your y value. Okay, so f of 2 is, well, let's plug it in. 3 times 2 squared minus 12 minus 2 plus 15. Okay, so we have to do exponents before multiplication. So 2 times 2 is 4. And 12 times 2 is 24. And then 3 times 4 is 12. We can do this lots of different ways. Let's say we get all of our positives first. 12 plus 15 is 27. So then we can take 24 away from that pretty easily to get 3. So we know that 2, 3 is going to be our vertex. So let me just draw a quick sketch. So 2, 3, 1, 2, 1, 2, 3. That's going to be our vertex. Now we know because of the A being positive, right, that it's going to face upward. I'm just faking this for now because I don't need a specific graph. This one actually doesn't ask me to graph it. So I'm just putting this, generic parabola here to help me answer all these questions. So the next question says determine whether there's a maximum or a minimum. Well, the arrows go up forever, so there's not a highest, so there's not a max. But there is a lowest point, and it looks like it goes through 3. So I'm going to say so this was part A. For part B, we know that there is going to be a minimum of 3. Just start putting some of these things in, make sure we're right. Okay, so 2, 3 is what we got for the vertex. And then we said that it has a minimum. The parabola opens upward and has a minimum value of 3. We're doing okay so far. Now the next thing says find the range. Okay. So the range, so we're looking at the y-axis. So we can see that our parabola, the lowest it ever is, so this is for the range. The lowest it ever is 3. But then it just keeps on going upward forever and upward forever. So the highest, we're going to put positive infinity. Now infinity always gets a parentheses. Because there is actually a dot at 3, right? There is a point there. We're going to put a square bracket on the 3 to let people know included. It is on the graph. So we're going to have to put bracket 3 all the way to positive infinity parentheses. Okay, now, on which intervals is it increasing? On which intervals is it decreasing? So let's see that. Okay. So this is like part B. So the increasing. Well, we can see that it's going up here, right? So this whole side of the parabola. Well, if you trace this back down to the x-axis, that's 2. So it's going to be increasing from 2 all the way to infinity. But if we look at when we're decreasing, we can see it's decreasing on the left side of that. This whole time it's decreasing. So that, the decreasing, is going to be from negative infinity all the way up until 2 parentheses. Okay. Negative infinity because, not because I'm looking at the y values, but because I'm looking at the x-axis, right? -1, -2, -3. I didn't draw it very well, but this parabola is widening, right? I didn't draw it very well. It's just getting wider and wider. So it's going to be decreasing for all of these x values that are heading off to negative infinity. So remember, always think about the x-axis when you're doing this. Don't think, oh, it points upwards, so that must be a positive infinity. Think when it goes to the left, it's a negative infinity. When it goes to the right, it's a positive infinity. Okay, so 2 to infinity is the increasing. 2 to infinity. And then the decreasing was negative infinity to 2. Now, one thing I do want to address is we're always going to use parentheses on these increasing, decreasing questions, because right here is where a decreasing meets an increasing. So at the value 2, you can't definitively say, oh, I'm increasing there. Technically, it's where a decreasing meets with an increasing. So we have to toss that point out. We have to throw it out. We can't claim it for the increasing. We can't claim it for the decreasing. So it's kind of like it's doing both. So how do we show that a point is not included? We show a point's not included with parentheses. So just make sure that you use parentheses when you're talking about constant increasing and decreasing. Okay, great. Got a little physics question here or calculus question. Let's take a look at it. How can we apply this math? Let's see. A toy rocket is shot vertically into the air from a launching pad 7 feet above the ground with an initial velocity of 152 feet per second. The height h in feet of the rocket above the ground at t seconds after launch is given by that function. How long will it take the rocket to reach its maximum height? And what is the maximum height? Okay, so big picture here that we have starting at 7 feet, right? We're going to launch vertically. So this rocket's going to go up into the air and then come down and fall back down into the ground. Now you couldn't see any of that because I'm drawing on top of myself, right? So what we're going to do is we're going to take the height and spread it out over time, right? So really what happened is I started here, I went up to about here, and then I dropped back down to the ground, right? Okay, now that's not the movement I just graphed. The movement was this, up and back down. But I have to show you the movement spread out over time. So that's what this parabola is. It didn't take this path, the blue path, but we spread it out over time. Okay, so if we want to find out how long it will take the rocket to reach its maximum height, well, it reached its maximum height here at the vertex. So basically, this is just asking us to find the vertex. A complex problem, but hey, we found the vertex on the last two questions. I think we're pretty good here. Now, normally it's x equals negative b over 2a, but there's no x here. The new x is t really, right? So we're going to say t equals negative over 2a. All right. So we can see that the b is 152 in our problem. So it's going to be negative 152 divided by 2 times our a, which is negative 16. All right, so we got negative 152 divided by negative 32. Let's see what that is. So let's see, negative 152 divided by negative 32. 19/4 or 4.75. I think 4.75 is more informative here in the real world. We know it's that many seconds because we found time, right? So I think we answered the part where it says, how long will it take the rocket to reach its maximum height? Well, if that 4.75 seconds, it's going to reach its maximum height. So let's go put that in. Cool. But now it says, what is the maximum height? Well, okay, we got the x value, right? Really the time value, but we don't have the y value over here. We don't know how high it went. Well, we know how to find the y value given the x value, right? You take what you got and you substitute it in. So let me clean this up so you can see it better. So we're gonna have to substitute that in here and in here for both the t's to see how high this thing goes. All right, so here we go. Negative 16 times 4.75 squared plus 152 times 4.75 and then plus 7. So I'm totally going to calculate this. Everybody would. All right, let's see what we got. 368. So it's like 368 feet. How high this rocket went. You know, we're measuring in feet for a few reasons. The problem mentions it. But if you see a negative 16 in front here, that means we're measuring in feet. Okay. All right, so 368 feet. Let's go put that in. Yeah, that front number comes from the acceleration of gravity when measured in feet per second per second. So if you see this negative 16, it's automatically feet, not meters. That would be even. Oh my gosh, I already forgot you guys. 368? Yeah. Okay, so 368. Cool. All right, looking good. It's nice to see the math that you're doing, actually apply, right? Okay. See, is number 15 solve? Grab all this because we might need it. All right, so for this one, there's lots of ways to do this. You can just cross multiply because it is a proportion. But what I'm going to do it in the spirit of how we've been doing it in class, and in case you're given something that's not a proportion. So we've been getting rid of the fractions by multiplying by the LCD. So our least common denominator is going to be x and an x plus 6. X and an x plus 6. So we're going to multiply by an x and an x plus 6 to all of the numerators. That way we can cancel those denominators out. That's the whole point. See you later, x plus 6, and see you later, x. So now what we have left, if you look at the left side, we have a 6 and an x. And we're multiplying, so it's got to be a 6x. And if you look at the right-hand side, we have 8 and x plus 6. And they're multiplied. Way easier, right? Now you can see that if you just cross multiplied, you would actually get that same result. So for those of you who are used to cross multiplying from maybe geometry, right? There's your 6x. And if you multiply this way, right, put some parentheses around it, there's your 8 times x plus 6. All right, so let's see what we got, guys. We got 6x equals 8x, and then 8 times 6 is 48. So I'm going to go ahead. You could do a lot of different things here, but let's say I move the 8x over to the other side. 6x minus 8x is negative 2x. And then I'm going to divide both sides by a negative 2 to make that negative 2 go away. So that's going to cancel the ones over here. So x equals, a positive divided by a negative is a negative, and 48 divided by 2 is 24. Now remember, you do have to check and make sure that this solution is not an extraneous solution. So you want to go in here and see if I put a negative 24 in there, I'm safe. It doesn't make the denominator go to 0. And if I put a 24 in there, it doesn't go to 0. Another way is before you even start this whole thing, you find your restrictions, right? And we find restrictions by setting the denominator equal to 0. So if we set x plus 6 equal to 0, we subtract the 6 to both sides, we can see that x cannot be negative 6. And then over here for the other denominator, well, you just set x. So x is not allowed to be negative 6 or 0. Well, we didn't get negative 6 or 0, so we're good to go. Negative 24 is an actual solution here. So we're looking at A, right? Check the A box and put negative 24. Cool. All right. Almost there, you guys. Few more. Now let's take a look at number 16. Okay. So the steps for solving a radical equation. I'm just going to write them out in case maybe you're making a note card for yourself. Okay. So steps for solving a radical. Number 1, isolate the radical. Number 2, raise both sides to a power equal to the index. Talk more about that in a second. Step 3, solve. And the oh so important, and I got burned all the time because I didn't do it. Step 4, which is to check. Really, you only need to do that if it's an even indexed radical. Even indexed. Okay, so let's use these, okay? So isolate the radical. Y plus 3 is the radical, right? So I have to get rid of that 2. So I'm going to add the 2 to both sides of the equation so that the radical is now isolated. So step 1, done. Step 2, raise both sides to a power equal to the index. Well, this is a square root, so we're going to raise both sides to the power of 2. We're going to square. If I had been, if it was cube rooting, that's my index, then I would raise both sides to the power of 3, right? So whatever the index is, that's what you're going to raise both sides to. Now, I do want to make a comment here. This is even, so we do have to check. Don't forget it. They love to put these in here so that you miss it, okay? All right, so the square root and the squared cancel each other out, so we just have y plus 3. And then 3 squared, 3 times 3, that's 9. Easy solving from here. Take away 3 and we got it. Yeah. Maybe, right? You have to remember to check. So let's check this and see if this actually is a valid solution. So we're going to put 6 in for the y and let's see what happens. Well, 6 plus 3 is 9. The square root of 9 is 3. And 3 minus 2 is 1. Okay, this works out. 6 is the keeper. So let's go put that in. Select the solutions are just one of them. Cool. Not too bad, but just make sure you check it. Okay, it looks like we're on to an absolute value and a pretty nice one. So remember with absolute values, you always do your 2 cases, right? One case is going to be x equals 5, 6. And the other case is going to be x equals negative 5, 6. And technically we're done. These are going to be your answers. But make sure that you understand why. If you have some absolute value brackets, and you're wondering, well, what could I put in there? You could put 5, 6 in there because the absolute value of 5, 6 is 5, 6. So that works. But you could also put negative 5, 6 in because remember, the absolute value means the distance from 0. And if you want to know how far negative 5, 6 is from 0, it's 5, 6 away. So absolute values don't change the sign. Absolute values turn everything positive because absolute values mean distance. And we never talk about distance negatively. When you say how far you are away from something, you wouldn't say negative 6 miles. You would just say 6 miles. So absolute values turn everything positive. So that is why both 5, 6 and negative 5, 6 work on this problem. So the solutions are 5, 6, comma, negative 6. Let's check it. Perfect. It's an easy one, huh? We're going to progressively get harder. We can see that at this next problem. This one's very similar to kind of the last 2, if you will. You have some steps here. Step 1, isolate the absolute value. Just like with radicals, right? Isolate the radical. So we have to isolate the absolute value. So what we're going to do is we're going to add this 3 to both sides. So now we have the absolute value piece by itself, and 8 plus 3 is 11. So once you get to here, you're going to do exactly what we did on the last problem, your 2 cases. X plus 6 either equals 11 or x plus 6 equals negative 11. Make sure you're only changing the right-hand side, that you aren't changing the stuff inside the absolute value. Okay, and then just solve these. So we're going to take those 6 from both sides, and the 5 for one solution. we're going to take away 6 from both sides. And negative 11 take away 6, it's negative 17. So our solutions are 5 and negative 17. Okay. Holy moly. Okay. Sorry, that's taking a long time. Is that all right? So isolate the absolute value, do your 2 cases, then solve. Okay. Still not too bad, but a lot of students forget to do the 2 cases. When I'm grading, that's usually the issue. Okay, so this one says solve it and graph it. Okay. So because it is a greater than, we're going to do 2 cases. We're going to say 6x is greater than or equal to 12. So basically everything's the same except for the absolute value brackets are gone. But on the second case, you have to change 2 things. You've got to flip this. Get a less than or equal to. And you have to change the sign on the 12. So it's a negative 12. Okay? So we had to do 2 things. Flip the inequality and change the sign. So let's go ahead and solve this. So if we divide by 6 here, we're going to get that x is greater than 12 divided by 6 is 2. Then if we go over to this other one and we divide by 6, we're going to get x is less than or equal to negative 2. So on a number line, we got negative 2 and we've got positive 2. At positive 2, we're going to go to the right because that says x is greater than. We're going to go this way. Remember that an or equal to means square bracket. Then for this one, it says x is less than or equal to negative 2. So we're going to go to the left at negative 2. And again, the or equal to means square bracket. So there's going to be a union. And there always is a union when it's a greater than. Sorry, you guys. Okay, so let's write this out. This is going to be from negative infinity all the way up until negative 2. You already know it's a square bracket. We've talked about it. That's that piece. And then this one's going to be square bracket 2 all the way to positive infinity for that piece. So this is the solution that they're looking for. Let's see if I can remember it. I think parentheses, negative infinity, comma, negative 2 brackets. Bracket, comma, let's see. Yes, so we got to graph it. Okay, well, the only one that has square brackets and is a union, right, is B. So this wasn't too bad of a graph here. The other one has parentheses, so it can't be that one. You better know your bracket and your parentheses, though. So otherwise you will miss it, right? Okay. Last one, you guys. Solve and write interval notation for the solution set. So I put both of these on here because I wanted to make sure that you understood that, or that you understand that you treat less thans differently than greater thans. Greater thans we do 2 cases on. For less thans, we take the stuff that's inside the absolute value and we sandwich it between that number and negative that number. So the less thans get sandwiched. They don't do 2 cases. Then we solve this 3-part inequality. So if you guys remember, we try to get the x by itself by subtracting 1, but we have to do it 3 times. That's what was different about this. So we have negative 6 less than 6x. These guys are goners. And 5 minus 1 is 4. Now we got to get rid of that 6 that's multiplying by the x. So we're going to divide. So negative 6 divided by 6 is negative 1. These guys cancel. And we're going to have to reduce that. So I'm going to divide both of them by a 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So this is 2/3. Remember that this calculator does reduce fractions. So if you're absolutely terrible at it, just pop it into your Casio. And this is basically your answer. So we're going to have negative 1, comma, 2/3. And there's no or equal to's on these. So that means parentheses. These are never unions. These are always one piece because you're always shading inward. At -1, 2/3, you're always shading between them. So it's always going to just be one piece, no union necessary. So that makes, for me, if it's multiple choice test, I go, oh, it's a less than, okay, no unions, and I'll cross off all the choices that have unions. Or vice versa. In this one, if it's a greater than, I know it has to have a union, right? Okay, because those always point outward. They don't point inward when you're graphing. Okay, so let's go put this in and pick it out of the lineup. So -1 to 2/3. -1 to 6 thirds. Let's see. Cool. That out of the lineup. This is the only one with parentheses that's one piece that doesn't require a union. The other one that's one piece has square brackets. So it is very important, apparently, you guys, that we know the difference between a parentheses and a square bracket. All right, cool. All right, so hopefully this helps you out with your chapter 3 test when you take it. Good luck. Thanks for joining me.